Okay, let's go over this one. This is 2006, question number 5. PV diagram. So you should, as you're going through these, you should really kind of mark things up, okay? So this is telling you the pressures, the temperatures, and the volume, right? Alright, find the temperature of the gas at state 2. There's really two ways to solve this problem, kind of the long way and the short way. For me, the short way is to basically remember that, well, we're going to use PV equals nRT. Since n and r are constant, we can simply say, well, PV over T should equal PV over T, right? And in this particular problem, for state 2, what did they tell us? State 1? They told us state 1. For state 2, something else is constant. What else is constant? Pressure is constant, right? So this even simplifies further. V over T equals V over T, right? And then you can just go ahead and substitute in. So V at state 1 was 0.25. T at state 1 was 373 equals V at state 2, which was 0.5. And T at state 2, which was, what was it? We don't know. And actually, this is even easier because notice 0.25 and 0.5, what happened? Well, it doubled, yeah. So if the volume doubled, what should happen to the temperature? It should also double. Okay? So you should end up with the temperature that is, therefore, 746. Okay? So this one was worth 2 points. 1 point essentially for the work and 2 points for the answer. You could have also used PV equals nRT and done what? Anyone do it like this? Solve for the number of moles and then use PV equals nRT again and solve for the answer. You should have still gotten the same thing. Okay, for state 3, you're essentially going to do the same thing. We're now going to state 3. You can use PV equals nRT or PV over T equals PV over T. This time going from 1 to 3, or you can go 2 to 3. Going from 1 to 3, what's staying constant? The volume. Okay, so volume is constant, so you just have P over T equals P over T. Okay, I'm not going to do the work. You should have gotten 560 degrees Kelvin for that one. This one was worth 1 point, okay, because you're more or less doing the same thing. Okay, so that's the first one. Number B, calculate the net work on the gas during the whole cycle. So the main equation for this is work equals, what's the main equation? Negative P delta V. Okay, and you're just going to do it for each cycle. So 1 to 2, 2 to 3, 3 to 1, and then the total. Okay, so that's kind of what you're going to do. I'll do the first one just to make sure we're on the right track. So 1 to 2, the pressure is 1 times 10 to the 5th. And then we're going to go delta V, that's final minus initial. Okay, final minus initial is going to be 0.5 minus 0.25. And that's negative, right? So you should have gotten negative, what's the answer? 25,000. Okay, negative 25,000 joules for that first one. And you're just going to go through and kind of do that for each. Now for 2 to 3, what do we use for the pressure? We're going to use the average there. Yeah, so remember when the pressure is changing, just go ahead and use that midpoint average there. So we're going to use 1.25 times 10 to the 5th. And this would just be 0.25 minus 0.5. So that's going to give us 31,250 positive. And then 3 to 1, well, this one you should be able to do in your head. What's 3 to 1? 0. And then you're just going to add them all up. Okay, so the final answer is like 6,250. This was worth 1, 2, 3, 4, and that's how they partial credited it. And you should say what the meaning of this is. Plus 6,250 means is work done on the system or by the system? On the system. Okay? Now you actually do not have to memorize that, because on your constant sheet, which is given to you for both parts, there's a little thing right here down at the bottom. It says, for mechanics and thermodynamic, W represents the work done on a system. So this would be the positive W represents the work done on the system. So if you forget that at any point during the test, it's right there for you. Okay, they do give you that. Okay, and lastly, what's the last one? Letter C. Was heat added to or removed from the gas during the cycle? Actually, real quick, let me show you one more way of doing B. One of the other concepts here is the work. Another definition of the work is the area done under the curve. So work is also the area done under the curve. So in other words, from 1 to 2, the area would be this. From 2 to 3, so it would be like this. From 2 to 3, the area would be this whole thing. And obviously there's no area for this one. So when you do the net area, really it's just the area enclosed by the triangle here. So the net area would just be the area enclosed by your cycle. Okay, so that's another way you can do that. And you would just find the area of that triangle. Let's just see if it works. So we go 1/2, it's a triangle, right? So base times height, so the base would be 0.25, and the height would be, what's that, 0.5? Times 10 to the 3rd fifth equals 6,250. Okay, plus. So that's another way of solving it when you want to find the net, is the area enclosed by it. Yeah.
If you just do the area enclosed by the triangle, would you get all the ones though?
You would, yeah, as long as you're showing where that answer is coming from. Yeah, if you would say the network is the area enclosed by the curve, and then you just did it. Yeah. Yes.
But if the triangle is like flipped, one dimension would be a negative.
Yeah, the arrows are important, so you would have to know, okay, which one dominates here. Is it the one going from 1 to 2 or the one going from 2 to 3? What's the answer? 2 to 3, okay, because it's above, and so there's going to be more work in there. And so to figure out the on or by, you'd say, well, 2 to 3, notice the volume's decreasing. This is an on process because it's decreasing the volume, and so you would know that it's on. And you're right, if it was reversed, then it would be negative. Okay, good question. Let's do last one. Was heat added to or removed? And the answer is, it was removed. Yeah, and how do we know it's removed? Here's how you should explain that it's removed, okay? Because, okay, so in a cycle, what happens to delta U? Delta U will be 0, right? You end up right where you started. So your explanation be something along the lines of this. In a complete thermodynamic cycle, delta U is 0, right? Because you end up right where you started. And we know that delta U equals Q plus W. Okay? Therefore, Q is equal to negative W. And since W was positive, Q is negative. So that, and in fact it would be, what was it, 6,250 would be our Q here. And negative means removed. So that would be kind of a thorough explanation that you would use. You should always, when they ask you to explain, point to your first law equation, okay, and go from there. So that was worth 3 points. 1 point for the removal, and then kind of more or less 1 point for saying something like delta U equals 0, and then 1 point for using the thermodynamic equation to get to the result of its being removed. Okay, any questions?